I'd like to welcome you all to this session on data-powered positive deviance. For those of us working in the international development or the sustainable development space, there can be a sense of two dominant narratives. A critical narrative around problems and challenges and even failures, or a narrative of hype about standardized top-down silver bullets. All you need to do is add this magical ingredient and you'll solve all of your development problems. What we often hear rather less about is local bottom-up solutions to development problems. And this session is about the hunt for those solutions. In parallel, data for development has sometimes felt like a hammer looking for nails. We know that it has tremendous potential, but we often struggle to extract real development value from it. Now, we're not going to claim that the methodology presented here is itself a silver bullet, but it's an interesting new approach. Or maybe we can say it's a new tool, like a screwdriver perhaps, to sit alongside all of those hammers. And its novelty lies in its focus within digital data sets. Much of our data for development activity so far has focused on the aggregate. For example, looking for broad patterns in the collective behavior of humans on social media or when using their phones. Data-powered positive deviance looks not for the aggregate, but for the outliers. Those data points which are deviant from the average and positively deviant, meaning that they outperform their peers, potentially providing those local bottom-up solutions to development problems. So this session will tell you more about our search for those outliers, those positive deviants. I'll firstly be in conversation with Basma Albana, who is the University of Manchester researcher who first originated the idea of looking for positive deviance using new digital data sets. Then with Catherine Vogel, who's head of the GIZ Data Lab, and Jeremy Boy, lead data scientist of the UNDP Accelerator Lab network, which together have led the effort to put data-powered positive deviance into practice. Then we'll have a short presentation from Hodan Abdullahi, head of exploration for the UNDP Accelerator Lab Somalia, and Gunnar Hesch, project advisor with GIZ, who've worked on one of the first DPPD, that's data-powered positive deviance projects, looking at land conservation outliers in Somalia. And we aim to leave some time for your questions coming up on Hoover. Do post them into the Q&A. We look forward to them. All right, without further ado, let me say hello to Basma, and maybe let's start at the beginning. How did you first come up with the whole idea of data-powered positive deviance?
Hi, Richard, and hi, everyone, and thank you for the introduction. So in 2015, I took a course on design thinking that introduced me to the concept of positive deviance, which at that time I found it extremely intriguing. In this approach, you look for outliers who succeed against the odds, you identify their uncommon and successful strategies, and you scale them within their communities. What I particularly loved about this approach is how different it is from the standard model of development. You look for success rather than failure, and you look for local wisdom and know-how rather than external expertise and interventions. 1 year later, when applying for my PhD, I was drawn to the field of big data for development, and I wanted to do my PhD in this field. But I believe that the biggest value of big data lies in its ability to complement traditional data. So the starting point for me was to look for existing development approaches that are lending themselves to traditional data and complement this data with big data. At that point, I couldn't help but remember the positive deviance approach and the analogy between the positive deviance of this approach and the statistical outliers in data. Sorry to your mute.
Yeah, you've taken these two worlds, if you like, or these two concepts, positive deviance, big data, we know all the potential, you've put them together. In putting them together, what did you hope would kind of emerge? What did you hope that intersection would achieve?
I hope that this intersection would provide a method that would enable development professionals to make good use of the existing increasingly available non-traditional data in order to identify local solutions and practices and strategies. The method is still at its operational infancy, holding both promises and challenges for the development community. But I hope that the evidence provided in the projects that we applied through this initiative with the GIZ, the Pulse Lab Jakarta, and UNDP Accelerator Labs would accelerate its adoption. And it's open source, so it's an invitation for everyone to iterate and develop this method and refine it even more.
Okay, that's great. You've talked quite a bit there about the method. I think you're going to be showing us a little bit to explain, okay, what is this data-powered positive deviance method?
Sure. Just going to share my slides. Can you see my slides?
Yeah, that's perfect.
Okay, great. So the data-powered positive deviance method follows the same 5 stages of the positive deviance approach, starting by defining the problem, determining the positive deviants, uncovering their uncommon and unique and successful strategies and practices, scaling them within their communities, designing and implementing interventions that would enable the scaling, and then monitoring and evaluating those interventions. The difference in the data-powered positive deviance method is adding this non-traditional data to traditional data across the different stages of the positive deviance approach. This enabled us to identify deviance in temporal and geographical areas that weren't possible before. And in order to add this non-traditional data, we had to adapt the method to accommodate for this big, decontextualized, noisy, and heterogeneous nature of this non-traditional data. I'm going to explain in the next slides how we did this kind of adaptation or accommodation. So the first adaptation was when we defined the problem in data-powered positive deviance, it wasn't enough to just define the problem. We need to ensure that data-powered positive deviance is actually a suitable approach and will enable us to achieve the desired outcome in solving this problem. So there are 3 main aspects to consider when ensuring this fit. The first is suitability, the second is feasibility, and the third is desirability. When it comes to suitability, we need to ensure that positive deviants do exist by speaking with stakeholders or doing a preliminary analysis of the data and making sure that there are those outliers. At the same time, we have to make sure that this is an adaptive problem, a problem that would require a behavioral change. And it's not just a technical problem. So if you're going to build a bridge or just install irrigation, this is not the kind of problem that would make use of the positive deviance approach. The second point, and this is the most critical point, which is the feasibility. So you have to ensure that you have the data that would enable you to capture the outcomes of this population digitally. At the same time, you have to make sure that you have the contextual data that will enable you to control for all the confounding factors that could have an effect on the outcome. The last point, which is the desirability, you need to ensure that this method is not creating harm to anyone or any stakeholder in this problem. And here we're talking about the positive deviants, the non-positive deviants, and the community at large. Are positive deviants willing to scale their practices? Wouldn't they fear losing a competitive advantage? Are there any negative unintended consequences from this application? If we scale a certain practice, are we depleting a certain resource that only positive deviants were aware of? So we have to take into consideration all of those aspects. The second stage is determining the positive deviants. Here we start to look for those positive deviants. And I'm going to use this funnel diagram to explain the beauty of this method, where it starts with digital, non-traditional data, a digital, readily available, accessible data that can cover the outcomes of an entire population. And here we're looking at proxies of direct measures. So for instance, if a direct measure is crop yields, here we will be using a remote sensing derived vegetation index like EVI or SAVI or NDVI. And here we're making use of the large coverage of digital data where it's most needed, because when you have a large population, you can identify more outliers, and outliers are actually rare to find. This way, it will be easier to generalize their practices at the end when you have a reasonably sized sample. The next stage after identifying or this digital performance measure, you need to group or cluster this population into homogeneous groups that are having very similar contextual and structural variables. Why do we do this? Because in the following stage, when we identify the positive deviants, we need to make sure that we're identifying them relative to their context and not in absolute sense. Why do we do this? Because this way, we're increasing the likelihood that the identified practices or the identified factors are individual level, their practices and strategies, and they are not like structural or contextual variables. So in the homogeneous grouping, if we're talking about a case of agriculture, we would be using like rainfall, temperature, and soil, those kinds of structural factors that are beyond the control of individuals. After identifying the positive deviants, we cannot say that they're positive deviants unless we actually go to the field. But there are ways that we can somehow validate if what we're observing is noise. Are they true PDs or are they false positives? And this is why the PD validation stage is extremely important. Here we are doing like desk research or visual inspection, or having discussions with the different stakeholders to ensure that there aren't any confounding structural factors that we missed out. Like if there was an intervention that is leading to the higher yields and we didn't capture it in the digital data sets, or there are irrigation points that are there, but we couldn't find them in the data set that we were looking into. So this kind of validation will lead us to a final sample for the field work. And this is extremely critical because the more the data you have, the better when it comes to identifying outliers. But the trickier it is when it goes to the field work, because this increases the expenses of collecting the data. So here in the positive deviance approach, we are starting with a large sample when it's most needed, when we're identifying outliers. And then automatically, this sample is filtered to a smaller sample that is where we can have the time intensive and cost intensive collection of the data. And here we also can see that we start with extensive use of non-traditional data at the beginning in the funnel diagram. And then as we go lower, we start adding traditional data more in order to filter what we're seeing using digital data sets. The next stage would be to discover the underlying factors. So we have a fieldwork sample, we have those information-rich small sample of positive deviants that are very likely, where it's very likely to find those uncommon solutions. We go there and we start collecting the data. We start with the sample of positive deviants to generate hypotheses of what they're doing differently and what could be a successful practice. But we wouldn't be able to make sure that those factors are actually the ones contributing to the good performance unless we make sure that they're exclusive to positive deviance. And we wouldn't be able to do that unless we actually compare them with the non-positive deviants. So after generating those hypotheses could inform the design of a data collection tool. This one would be more of a quantitative tool that would cover a sample including both the positive deviants and the non-positive deviants. And this is when we can actually make this, or we would be able to identify significant differences between both groups and identify those predictors that are leading to this high performance. After identifying those significant predictors, they then could inform the design of either community interventions or policy interventions. So if they are at the individual level, like individual practices and strategies, then a community intervention will be suited. But if they are some factors like policies or some governance schemes, that's when we can actually consider doing a policy intervention. After doing that, in stage 5, using the same digital performance measure that we use to identify the positive deviants, it would be possible to monitor and evaluate those interventions.
That's great, thanks. And I think Hodan and Gunnar are going to be illustrating for us a bit later on, at least the relatively early stages. So and also we're going to be giving a pointer to where people can find more details about that method. So I think, I mean, kind of just summing up, if you like, what's different and unique then for data for development. Is it right? I mean, it's this issue of the positive deviance, and it's also these combinations of data. Is that right, Basma?
Yes, and there are, like, to the best of my knowledge, there are two other possible differences between how data for development is currently done. So the first part is, or the first difference is how predictive analytics is used. So in the current data for development methods, predictive analytics are used to estimate and predict the characteristics of the population, to develop poverty maps, or to prioritize resource allocation. In the data-powered positive deviance method, we're using predictive analytics in a different way. We use it actually to predict the performance of a population based on their contextual and structural conditions. And those predictions are then used as the baseline from which positive deviants are identified. So to give you an example, we train a model, for instance, to predict crime rates in a certain area based on their mobility, their socioeconomic and demographic conditions. We then calculate the difference between what was predicted and the actual crime rates that were observed in this area. Positive deviance in this case will be the areas having much lower crime rates than what was predicted. So this is the first difference. And the second difference is in the type of the traditional data that is combined with the non-traditional data. In this method, positive deviants act as information-rich units that could be targeted for the thick data collection. And by thick, I mean like data collected through qualitative and ethnographic methods, which are better able to explain the why and how of what we are able to observe. Systematic ways of integrating big and thick data are lacking in the data for development practice, and the data-powered positive deviance provides one way of doing this integration.
That's super. Okay, so thanks. So thanks very much for telling us kind of where this all came from, and then exactly what are the steps and stages of applying the method. You've developed these ideas, and a significant way in which you've developed these ideas has been them being put into practice with our colleagues from GIZ and UNDP. So turning to them now, Catherine, when you first heard about this idea, what was it that first attracted you to this idea of data-powered positive deviance?
Well, the first thing, I mean, I co-coordinate the GIZ Data Lab, and there we're all about looking for innovative ways to use data for development and doing things differently. And that was exactly what attracted me. Like just the idea of doing development differently, of promoting local creativity and local solutions, local knowledge, but at the same time using the benefits of digital data, what we do at the Data Lab all the time, in terms of time series, accessibility, etc. So that potential really struck me. Improving our evidence and our targeting, and at the end of the day, also our impact was very intriguing to me. And then, I mean, also just the excitement of innovation. I mean, this was something which hasn't been done before in that way. And I saw the potential, what happens if this really works, and what if it will? Will this change the way we approach development cooperation and our interventions? And so when I first heard about it, that was also the time when we started to work together with Pulse Lab Jakarta, who is always on the hunt for these innovative solutions, but also the time when the Accelerator labs were born, and Jeremy will talk about that. So it really felt obvious to join forces in that adventure and try it out in the field.
Thanks. So Jeremy, now your perspective from UNDP Accelerator Labs.
Thank you, and good morning, everyone. Yeah, so in the Accelerator Labs, we're a network of 91 social innovation labs distributed and working with 115 countries and embedded in the UNDP organization. And the labs have, on the one hand, a mandate to tap into new digital sources to try and understand development problems, and on the other hand, a mandate to map what we call grassroots innovations or do solutions mapping And what was really intriguing and really exciting is that, as Basma presented, this data-powered positive deviance approach really is at the intersection of the two. You use, the new sources of data to try and uncover these grassroots solutions. And so it was just basically a perfect fit for us.
That's great, thanks. So we had this kind of partnership, those of us at University of Manchester, UNDP, GIZ and Pulse Lab and so on, came together and produced a series of projects. So Catherine, maybe, would you be able to tell us a little bit more about the projects that emerged?
Yes, thanks, Richard, and thanks for mentioning University of Manchester, which is really like our mastermind in this whole endeavor. So when we started to think about how we best approach trying this out and this adventure, as I called it, we knew that we need to understand it in various contexts, in various sectors, but also geographical areas, with all the challenges and baselines and everything which come with it. So when you have a look at the map, you can see our the pilots we run with the Accelerator labs, but also Pulse Lab Jakarta. In Indonesia, but also then there was one in Germany with a broad range of researchers where we worked on COVID-19. To give some examples, many are related to agriculture. So in Niger, we worked on rain-fed cereal farming, looking for those who outperform the farm yields. And then in Ecuador, we looked at those farmers who had the advantage, or who performed better in not deforesting the Amazon region in their cattle farming. Rice farming, as I said, in Indonesia, looking at those who outperform their peers with regards to yields. In Somaliland, we looked for pastoralist communities which managed to have healthier rangelands. And in Mexico, we looked for safe spaces for women with regards to, or compared to other spaces. So this is also one which is outstanding because we're not looking at the behavior, but we're looking at more structures and at spots in a city. So you can see it's not only very diverse in the application of the sectors, but also you can try it in all different backgrounds and internet connectivity situations, etc., etc.
That's great, and I think I see Cities asked a question in the Q&A about where's this been applied. So hopefully that's given a sense of an answer to that question. Those were the original pilot projects. I should say as well that we had a boot camp a few months back, and that's added a group of new projects that are now coming through in the pipeline. So we've had some experience at least of data-powered positive deviance. Jeremy, on reflecting on those projects, what do you feel has been learned for the data for development community, for example, in terms of good practices in using data for development?
So yeah, good question, Richard. This actually offers the opportunity to advertise that we are right now releasing a learning report based on the work that we did jointly. So the UNDP Accelerator Labs, the University of Manchester, and the GIZ Data Lab in Ecuador, Mexico, Somalia, and Niger. So a subset of the ones that you just saw. And we compile 6 learnings really around the data work that we did in each of these pilots. So I'm not going to go into detail of all of the learnings. I invite you to go and download the fresh off the press report at the URL that you see at the bottom here of the slide. But I'm going to focus on 2 and try to expand a bit beyond what we wrote in the report. So if I make this full screen. But before I jump into the specific learnings, I just wanted to share this image that I think really nicely illustrates a few things that have been said already. So at the very beginning, Richard, you mentioned, looking at the aggregate versus looking at the outliers. And
sorry, Jeremy, it's not showing up on my screen, the image, I'm afraid.
It's not.
it was still showing as the original. There you go. Perfect.
Can you see it now?
Oh, I could, but then it disappeared.
Someone stopped sharing. Got it?
Yep, that's
great.
Good.
So yeah, so this typical problem of focusing on the aggregate and throwing away the outliers. So obviously this picture really nicely illustrates it. Unfortunately, I can't give credit to the person who made the meme because I found it on Twitter and couldn't trace it all the way back. But I think this picture also shows something else that's very interesting that Basma mentioned in the idea of desirability of applying the method. So I don't know if it's just me, but if you look at this lobster, it seems really happy to be thrown back into the water. And I think this is something, that we should always be mindful of. Looking at deviance to identify these grassroots solutions or innovations that might help contribute to the development problems, but these people have competitive advantages potentially in their communities. And so is it desirable from our perspective indeed to go in and put the lens of focus on these people, or is it better for them to actually just leave them in the sea? So coming to the two learnings that I wanted to focus on from the report, the first one is map and fill know-how gaps early. So in the report, we talk about, the necessity of having people who are technically competent throughout the whole design process, throughout the whole process that Basma described essentially. And even if we have, essentially two phases, the more data intensive quantitative phase, and then the more ethnographic qualitative phase, it's really important to have people who can also, accompany all the way through the transition between these two phases. And so knowing what type of technical capabilities are necessary and having them on board throughout, again, the whole design process and the whole implementation, turned out to be really critical in what we did. But I want to go a bit further here with an anecdote from the pilot in Niger, where we were able to find a brilliant young woman who had done her PhD at the intersection of remote sensing analysis and agronomy in Niger, focusing on the same types of cereal crops that we were looking at and so on. So she was the perfect fit. She had the contextual knowledge, she had the technical knowledge. She was in Niger, so she was, close to the field and so on. But she couldn't download the data that we needed to analyze what to do the analysis. And so ultimately here, an infrastructure problem made it impossible to go further with this person who was actually probably one of the best to do the work. And so I think there are two takeaways here from this short anecdote. One, that there are skills everywhere, and that data for development is not necessarily just something that has to happen in the global north, or that can happen in the global north. The second one is obviously there was an infrastructure problem, and I think there needs to be therefore typically in large organizations a better, not to say that they're disaligned or that, but a better alignment between digitalization agendas and data agendas, or digitalization strategies and data strategies. Of course, they go hand in hand, but they are often somewhat disconnected or somewhat, indirectly only connected. So I think this example really, pushes for that. The second learning that I wanted to focus on here is what we called in the report scale with caution. So in the report, we mentioned this because, as Basma said, there is the potential to look at larger sample sizes, cover broader geographic areas, look at things over time, because digital data is collected relatively more frequently, and it's easier to collect and access typically than ethnographic or anthropological data that requires extensive fieldwork and so on. And so, yeah, in the report, we talk about, this potential, but at the same time, the more you scale, the more obviously there are potential confounding factors that come into play. And so when you start modeling, when you start to try to predict things, you have all these potential variables that obviously you can't all account for. And so you have to be careful with that, and you have to do it with caution. But there is another aspect here, I think, that is worth talking about. So in Ecuador, at the transition between the two phases, between the data intensive, the quantitative and the qualitative phase, there was this issue of, how do we socialize essentially the results of the data phase with the farmers themselves, so the cattle farmers operating in the border of the Amazon forest. And the team there did some great work, where to socialize, what they did is they asked the farmers to draw on maps what their area of operation was, what they considered their farming areas were. And there was a discrepancy between this and the cadastral data that we had been using to model and predict essentially whether there was deforestation on a farm in the region. And so this really points to, I mean, the well-known phrase of the map is not the territory, but there was this discrepancy then in the fact that everything that we had based on our analysis on, everything that we had considered, reality because it was the data, was actually obviously just an abstraction or an interpretation of what was reality for the people on the ground. And so in scaling here, maybe I'll phrase it in this way, the data are, a meaningful abstraction at a point in time. The more you scale and the more you model, the more you might lose, you're likely to lose that meaning in the abstraction. And so here, again, this is really the point I want to make, is that scaling introduces obviously confounding variables, but also, again, abstracts more and so loses the connection with potentially the territory. That being said, I think DPPD, the data-powered positive deviance approach, has tremendous potential, as Basma was saying, in joining these two ends. So Basma was talking, about the integration of big data and thick data. Here, I think when done properly, when there's proper interaction between the field work and the more quantitative work, there is an opportunity to, reduce the gap essentially between said map and territory.
That's great. Okay, thanks very much indeed, Jeremy. I notice we've got some questions coming in from the audience, so thanks very much for putting those in. City again is saying, in the PD method, is the traditional data used as ground truth? I hope that you've seen to some extent from the answers given by Basma, what Basma and Jeremy particularly have said, that the answer to that is yes, it is. So we've heard kind of the background to where this data-powered positive deviance idea came from, what the method involved, how it was then scaled out to a series of pilot projects, and some of the things that we've learnt from that. What we're now going to do is have an example of one of the actual projects that apply data-powered positive deviance. So I'm going to hand over at this stage to Hodan and to Gunnar to tell us about the DPPD project in Somaliland.
Okay, thanks, Richard, and hi, everyone. So I'll just start with the problem itself that we were focusing on for Somaliland, which was the severe land degradation and loss of rangelands beyond repair, especially after the droughts of 2016 and 17. And this is particularly disastrous to a country that a large segment of the population are pastoralists and dependent on these natural grazing resources. So Gunnar, if you can share the screen, please. So if we want to look at our problem from the lens of a data-powered positive deviance, we need to think of suitability, first of all. As Basma alluded to before, we have to see how how this method is suitable for our problem. So the nature of our problem is complex and combines spatial, temporal, environmental change. There's societal change, population change, and all of that having direct or indirect effects on rangelands and would require adaptation and resilience and a certain change in behavior. And by having discussions with stakeholders, we found that indeed there is a possibility that there are positive deviance on the ground. And then the question becomes now, can we find communities who successfully maintain their rangelands through their actions and adopted practices? And for that, we need to see if it's, let me just share my screen. Yeah, And then it would be, if it is actually feasible. So through the different projects and initiatives that were going on by different organizations in the past 10 years, there's a huge collection of digital data on livelihoods, population, natural resources, and on Somalia especially, and Somaliland in the north, and as well as the increasing availability of digital data. In this case, remote sensing data, GIS, and satellite data. And we were also lucky to have GIS analysts on board who helped us on this on that side. So then, oh sorry. And then the thing is it desirable? When we find these positive deviants, is it desirable for us? Will they be willing to share their knowledge? Is it desirable from a development perspective? And initially, yes, it is desirable because of two things. Firstly, because there's a promise of sustainability. When we have homegrown solutions, there is a big possibility that they would continue after the intervention or after they are scaled up, because there is buy-in from the local community. And then when we scale these practices, there is a huge possibility that we will have much more impact on the environment, hopefully. And I'll just stop sharing, and I'll pass it on to Gunnar to take us through the positive deviant discovery.
Thank you, Hodan. Sorry for the technical mishap. I start sharing my screen as well. Okay, Jeremy, I'm not yet allowed to share my screen because
Gunnar came out, so you need to make him co-host if you can, Jeremy.
Okay, now it should be working.
Yeah, it's
Can you see my
super.
screen?
Yep, thanks.
All right, great. Thank you. Sorry for the mishap. So here we are looking at the West Golis region in Somaliland, and this was our area of interest. And I would like to give you a quick rundown of how we identified potential positive deviants using the available data sources, like, for example, remote sensing and other geodata sources. We first had to decide what our unit of analysis was going to be. For this, we used the populated places dataset by World Bank and buffered these places with a radius of 5 kilometers. We determined these 5 kilometers after some interviews with pastoralists, and this is our best guesstimate for daily movement radius. We now wanted to figure out if the pastoral ecosystem is performing better in some areas, which could in turn be our potential positive deviants. To be able to assess ecosystem performance, we had to create, as you remember from Basma's talk, homogeneous groups to be able to compare apples with apples and not apples with oranges. To make the ecosystem comparable, we had to consider two main variables. The first variable is land cover, for which we used the data set by the European Space Agency based on the PROBA-V satellite. And we visualized this in the first map on the right, with the two dominant land cover classes, barren land in gray and shrubland in orange. The second factor is rainfall. Here we used the precipitation data set and aggregated the precipitation in the growing season. And this is visualized in the blue map. Using these two variables and the clustering algorithm, we then created our homogeneous groups, which you can see in this very colorful map, the third one. So why did we do this? As mentioned before, we wanted to make ecosystem performance comparable. Looking at homogeneous groups, we took the liberty to simplify things a bit. We used satellite imagery. We calculated vegetation indices based on these images. And the higher the index, the more vegetation, the better the performance. This simplification was made possible only because we did the grouping first. Otherwise, we would have compared the vegetation index of a forest with the index of a shrubland, for example, or of an arid region with the very humid region, which would certainly not lead to meaningful results in our analysis. We now took the maximum measured vegetation index per group per year and compared each pixel in this group with this maximum value. This method is called SAVI scaling, SAVI being the index, and allows us to see how a pixel performed within its own group. And we did this once for each year between 15 and 2020. Then we looked at each pixel and assessed how it performed over those 5 years. Of course, we didn't do this ourselves, but rather used raster mathematics and statistics to do so. And in the end, we had a Z-score, and a very high positive Z-score told us that the vegetation in the pixel was increasing, and a high negative Z-score told us the vegetation in the pixel was decreasing, always keeping in mind the relative performance within the group. One thing I'd like to mention is these methods do not allow us to control for the quality of vegetation, but it's purely about quantity at this point. And I think it's important to keep that in mind and not overestimate what's possible using those methods. But still, we could get a good overview of vegetation development overall. We then took the mean score of the settlement areas. We determined the first step. You might remember those pink bubbles. And took the best performing settlements as our potential positive deviant areas. We also looked at the pixels with the best Z-scores overall and selected the settlements in which we could find a lot of those. Interestingly, rather assuringly, these two selections had a very high overlap. These well-performing settlements are highlighted in green on this map over here. And those are the settlements we determined to be our potential positive deviant areas. Lastly, we checked on those settlements, which we thought might be promising, and the divisional inspection of those. We did this jointly with Hodan and the UNDP team in Somalia, and also with the postdoctoral researcher who is originally from this region. Here, we can see the workflow we used for this validation. So we checked, for example, are there settlements? If no, then it's potentially not human intervention, what we're seeing. Is it an agricultural area? Because we're focusing on pastoral regions. Can we see human interventions in some form? And if the answers fit to our schedule, then we would be looking at a potential PD area. Then also some more practical or more pragmatic questions come into play, like, for example, is it accessible? Can we visit the region or not? And also, can we see some interventions? Do we have some third-party knowledge on interventions happening? To give you a quick example of how this looked like, here, for example, we can see two potential PD areas. On the left, we can see large areas of soil erosion, where surface water runoff led to soil erosion. And you can see that there's a hedge which has been planted to serve as a barrier against this erosion. This is some of the behavioral patterns we are looking at. On the right map, you can see half-moon structures, which are used to reduce surface water runoff. So the water flow of surface water would be in this direction, as you can see on the blue arrow. And these structures are used to reduce runoff and increase infiltration of surface water into groundwater. These are just a few examples of how we did this validation in the desk research. For more details on how the field research is going, I'd like to refer back to Hodan.
Thanks, Gunnar. If you could just go to the next slide. We've just finished the fieldwork part of data collection, the thick data collection, where we did a lot of focus groups, individual interviews, stakeholder meetings to map out what's on the ground and transhumance and different things the people would tell us on where they were at the point, at different points in time. So for the first example, you could see here in this picture, there's these stones. These are actually one of the methods and practices that we found interesting in one of the PD villages. This is kind of a horizontal line. It's called the loose stone method. And what it's trying to do, or what the people are trying to do, are to capture moisture, especially after rains, and slow down the trickling of water, rainwater, and as well as soil, because there's a lot of when floods come, a lot of the topsoil is taken down by the rains. And this was very interesting. We could see it from the satellite imagery, but it was interesting to find on the ground and how much it was practiced. So the next one, please. And here you could see the one of the new livelihood practices that were adopted by people in this village. We found that they have taken up honey bee farming, and this had kind of an indirect effect, or you could say a direct effect, on the environment in this area, because there's a big motivation for people to keep their trees and not cut them, whether it's for energy uses or any other use, just to protect the shrubbery and trees. The next one. The next one, you can see there was also in one village a communal enclosure. You could see here the fenced area is an enclosure that is intended to only be used when there is need. You can see the stark difference between the grass and grazing resources and trees in that area and the other one that is not being enclosed. And you can see here there's overgrazing, and yeah. So these are some of the interesting findings that we found, initial results. So over to you, Richard.
That's super. Yeah, thanks very much indeed to both of you, to Hodan and to Gunnar. And I think Hodan's the last slides there perhaps address Siti's question again to some extent about the kind of the ground truthing that needs to go alongside the analysis of the digital, the non-traditional data sets as well. I noticed we've had a number of questions coming in, so I'm just going to go through a few of those. So Najmi's question is essentially, what comes first? Is it data? I mean, the question is data or research objectives. I kind of think maybe it will be, is it the data or is it the development objectives that come first? That's, I think, a question around the DPPD method. So Basma, would you like to answer that one?
Yeah, thanks, Richard. So we always start the projects with a development problem. So what is the development problem? What is the desired outcome? What would you want to achieve from this project? And after defining the problem, along with the community, along with the local governments, comes the part of the research. So research is done at the same time as we're doing the development. So comes the part with the research where we can see and check what is the research telling us in terms of digital data sets that are capable to capture this desired outcome for this specific region and for this specific context. And after identifying this digital data set that can do that, comes the other question is there data that is readily available and accessible for this region that we can collect in order to identify this, those positive deviants or outperformers? And after doing the research and identifying those outliers or positive deviants, we go back to checking our resources, identifying if we can actually do the project, go there. So there's always like this going back and forth between research and actually doing the work and collecting the data. I hope that answered the question.
It's a kind of, as you say, one always starts with the development problem and challenge to be solved, but it's a bit of a sort of iterative dance at first between what's the data we've actually got, and what's the development problem then, and sort of moving together until you get them into synergy. Yeah, no, that's super. Marie-Louise asks, what in practice is the role of local communities, local government, local private sector in projects? Who would like to respond to that?
I can respond. Okay, I can respond to that.
Yeah, Basma, go ahead.
So the local communities and the local governments are extremely important in defining the problem at the beginning. So what is the problem and what would be a desired outcome for them? So this kind of discussion is critical with the people on the ground. Another thing is who would be considered a positive deviance. So for instance, when we were talking in regards to the Ecuador project on what would be considered an outlier farmer when it comes to deforestation, there turned out to be a definition of what a positive deviance could be. So it will be any farmer who deforested less than 2% of their forest area in the last 3 years. And based on their definition, we defined this as our cutoff point in order to identify positive deviance. And this was actually extremely important because we have to speak the same language and have a common understanding of what good performance could be, because this is only when we can get their buy-in, we can make sure that the findings from this analysis would be relevant and useful to them. So this is the first part of engaging the local partners. Later on, when it comes to identifying positive deviance using the quantitative part, when it comes to validating those potential positive deviance, that's when we bring back the local government and the local players and the development programmers to ensure that what we're seeing is actually true, and there is something interesting to go there. If they are not able to explain what we're seeing, then there is something that is unexplained that requires going to the field. So this kind of validation is extremely important with those local stakeholders. Now comes the part of going to the field and uncovering the underlying practices. This is done in a very similar way to how positive deviance in the conventional method is done. Positive deviance relies heavily on community participatory approaches that involve the community in scaling and amplifying the practices, because it believes strongly in the idea of self-efficacy. When people see people that have very similar resources, have very similar conditions, doing well, that's when they believe that they can actually do those practices. So the positive deviants themselves are the change agents. They are the ones who we bring them together with the non-positive deviants. They're the ones who say how they develop their solutions and why they develop them. And that's when the stickiness factor happens, or this kind of amplification of the solutions happens. So the community and the local government are together with us all the way from the very beginning till the very end.
Jeremy.
Thanks. Yeah, maybe just to complement what Basma was saying. So indeed, I mean, there are obviously multiple layers of stakeholders or key informants that we work throughout. But maybe to tie it into the previous question as well, I think there's all the key informants and the partners and so on around the development problem. The people who are directly in contact with the local populations and so on, but also around the data. And this is something that we found really useful in some of the pilots. The pilots started already embedded in broader projects that already had mapped out where all the data were, what was available, what was accessible. Many already had access to the data sets and so on. And so I think these might actually be the same stakeholders, the same partners. But if they're not, I think it's important to always think about these two tracks together. And so yes, the community, the people around, ultimately the beneficiaries, but also around the data.
Okay, that's super. I've got an eye on the time. So Stefano's got a question about the relationship between global development and positive deviance. I think I'll just sort of say myself that hopefully you'll have seen from a number of the illustrations of the projects, and if you look at some of the resources that I'll just be reminding you about in a second, you'll see that it is sustainable development goals that are driving these projects. And as Basma said, that's what we start off with when when we put the projects into operation is to first of all start with, well, what's a development problem or a challenge, and therefore inevitably what's a development goal that we're seeking to achieve with that. I'm just going to end by sharing my screen, and hopefully that'll come up and you'll be able to see various of resources there. So I'm going to draw the session to a close now. I want to thank all of the speakers in the session. I also want to thank a number of people a little bit more behind the scenes. Those the technical staff who've been supporting the session from the conference. Also 3 people who've been very much involved with the DPPD initiative, which is Andreas Glucker, Andy Powelka, and Lena Simarek, who've been with us on this session, and you'll have seen some of them posting in the chat or posting things in the Q&A. And of course, I also want to acknowledge the work of all of the pilot teams. Catherine explained what the various pilot projects are, and it's only through the work of those teams, people like Hodan and Gunnar and many others around the world, that have led us to be able to develop this data-powered positive deviance approach. So we hope you've had an opportunity during this session to learn something about data-powered positive deviance. Just to repeat our earlier messages, this isn't a silver bullet that's going to be able to discover and scale best practices in every possible development domain. And we are still at a relatively early stage. You'll notice we referred to the first batch of projects as pilot projects, and then we've got this second tranche of projects that are coming through after the boot camp, but we're still at fairly early stages there. But we can see already that this is an interesting new method that's already been able to make some new uses of data to identify new development insights. Our projects will continue as we move further along the stages of the method, but what about you, our audience? Would you like to know more? Would you like to set up a data-powered positive deviance project? If you would, we'd like to offer details of resources to help you with next steps. If you'd like to passively consume some further information, we can offer you the main project portal, which is listed there first, www.datapoweredpd.org, and that links to the other resources that are shown here. Further detail on how to apply the DPPD method is shown in that the manchester.ac.uk link, which has also been posted in the chat and in the Q&A. And then a richer how-to guide on running a data-powered positive deviance project that's going to appear shortly in what we call our cookbook. Jeremy already referred to our learning report, which tells you about our projects to date and the key lessons that we've learned about how to best implement the early stages, at least, of the method. And you can find some shorter items and descriptions of the projects that we've been undertaking on the blog link there. If you'd like to be a bit more interactive, and particularly if you've already started to do some data analysis of development outliers, then you can join the community of practice on Discord that's shown there. Or alternatively, if you'd like to start with some more one-to-one interaction, please get in touch with our DPPD contact points. They can talk to you about the support that we may be able to offer, and also about plans for further online events where you can learn in more detail the things that this taster session has covered. Above all, we hope to have given you some new inspiration, some new insights about the use of data science for development, and thank you very much for your time. That's the end of our session.
Thank you, Richard.
Thank you, Richard.
Thank you.
Thanks.